Hi. In this video we'll be discussing complex numbers, and the goal is to be able to do some simple computations with these numbers. So what does a complex number look like? I wrote down two examples here. So a complex number consists of a real part, which is the 2 in this case, and an imaginary part, so something with an I. And for this I we have the rule that I squared is equal to -1. So in general, when we do computations with complex numbers, we treat this I as a variable. And then at some point when we run into I squared, we simply replace it by -1. And then the result of our entire computation should again be a complex number, so something of the form a plus bi, where a and b are simply some numbers. So let's start off with a very simple computation, so we'll try to add up these two numbers. So we want to compute z plus w. So let's write this elaborately. So 2 plus 3i plus this w, so 5 minus 2i. So the real parts can simply be summed together, so we get 2 plus 5 is 7. And for the imaginary part we do the same, because we treat it as a variable. So we get 3 minus 2, so plus I. And that is indeed of the form a plus bi, so we are done. So addition is very simple, and subtraction is also simple. It's almost the same. So we want to compute z minus w. So 2 plus 3i minus 5 minus 2i. And just as normal, when we get rid of these brackets, so we have 2 plus 3i minus 5 minus minus, so plus 2i. And then we have again a simple addition, so we get 7 plus plus, so plus 5i. Oh, sorry, I see I made a mistake here. This is 2 minus 5, of course, not 2 plus 5. So this should be -3. All right, let's get into something that is slightly more complicated, so multiplication. Let's multiply these two numbers. So we want to do z times w. So we get 2 plus 3i times this 5 minus 2. So the first step is we simply want to get rid of these brackets. So we get 2 times 5 is 10, plus 2 times minus 2i, so minus 4i. And then here we get 3i times 5, so plus 15i. And then for the last part we get 3i times minus 2i, so minus 6i squared. So finally we run into something interesting, so we get an I squared. So we will simply, like I said before, we will replace this by -1. So then we get 10. Let's take these together, so minus 4i plus 15i is plus 11i. And then here we get a -1, so we get plus 6 instead of -6. So the total is then 16 plus 11. All right, so these are the very basic computations. And now the next step is to do division, which is slightly more complicated, but if you know what to do, it's not that bad. So let's try to write division here. So we want to divide z by w. So we have z is 2 plus 3i divided by 5 minus 2i. And now there is some complex number in the denominator, which is not so nice. So we want to try to make that just into a real number. And we are going to do that by basically multiplying by 1, but we write 1 in a nice way. And we will write it in a nice way by multiplying with the conjugate of this number, which means we replace this minus by a plus. So we do 5 plus 2i. And to get 1, we should also do this at the top. So let's try to work this out and then see why it works in general. So at the top here, we get 2 times 5 is 10, plus 4i, plus 15i, plus 6i squared. And at the bottom, we get 5 times 5 is 25, plus 10i, and then minus 10i, minus 4i squared. So this is nice because this is going to go away. So then what we end up with, we have this I squared here, so we can again replace it by minus 1. So let's first write the top a bit more nicely. So we had 10 plus 6i squared, so minus 6. So we get 4 plus 19i. And then at the bottom we have 25 minus 4i squared, so plus 4. So we get 29. So now to get something of the form a plus bi, we simply divide both of these parts by this 29. So we get 4 over 29 plus 19 over 29 times I. So now we are back in the form that we should have had, so we have solved our division. So now maybe to notice why does this multiplying by the conjugate always work. So we have in the denominator something of the form a plus bi, and we multiply it by something of the form a minus bi. So what happens if we compute this, then we get a squared minus abi plus abi, and then minus bi squared. So these again go away, and then we are left with a squared minus bi squared, so simply a squared plus b squared, which is always simply a real number. So then we always get some nice number in the denominator, and we can just divide the both parts. So this is what I wanted to show you about complex number. So hopefully you can now do some easy computations yourself. Good luck.